Hello everyone, today in this video we'll be discussing the IoT super important questions from the external point of view, and in this PDF I have included the answers in much depth and I have not answered all the questions. I have answered just those questions which are super important, and few of the questions which have been marked in bold. Those are the super important questions which you need to focus. So without wasting more time, let's get started. Make sure the like button, subscribe to my channel, and let's begin. So in the module 1 I have just answered the first five questions. The remaining ones are the questions which you have to look up for yourself, because all the questions I will not be answering. These questions can be found in the official notes, or else you can even watch the theory video in that I've explained. Okay, so let's get started. What does IoT mean and digitization mean? Elaborate. Okay, that's the first question. IoT means what? Focused on connecting the things. Internet of things means what? Connecting the things. If you have different things which are separate, you will be using IoT, Internet of Things, to connect all of these by using sensors and connections. Okay, so examples are given here, go through it. And digitization means that whatever is in the reality, that you are digitizing it. Okay, that is what is called digitization. Moving on, we have the second question, which is, with a neat diagram, explain the M2M architecture, IoT architecture. There are three types of architectures: M2M and World Forum, and the last one is simplified. Okay, so each of these three are important. So let's have a look at that. M2M, in the M2M, we'll be having the following layers: the application layer will be there, services layer will be there, network layer will be there. As the name suggests, they are for the same purposes. You just have to write what is that. Okay, so these are the three parts of the M2M architecture. And what is the simplified IoT architecture? Also they have asked. In simplified IoT architecture, you have the core IoT functions and IoT data management and computing stack. Okay, and what is the applications, communication network things, and sensors and actuators? All of these three combined to form some functions. Okay, what are the functions you need to perform the applications and the solutions? All these three perform, and there is a security layer in between. And cloud, fog, and edge layer is nothing but in what layer you are going to use the data. Okay, like for the different types of latencies, we'll discuss in depth regarding these three, so don't worry about that. So if you want more information regarding that, refer the notes or watch the theory video. Okay, third super important question: what are the different challenges in IoT? Okay, so these are the challenges: scalability, security, privacy, big data analytics, and interoperability. The more information is given here, go through it. Next, we have the discussion of IoTWorld Forum, IoTF standard architecture. You remember we had OSI model in that 7 layers were there. Like that only here also we have physical devices, and that will be given to the connectivity, and that will be sent to the edge connectivity, data accumulation, abstraction, application, and collaboration and process. Okay, so this is the architecture which you have to explain. Moving on to the IoT data management and computation stack. This is nothing but the same thing here, which is present. Okay, this one only we are discussing. So in that, what you have is the cloud, fog, and edge. Okay, so what is cloud? Let's have a look. Cloud computing refers to the use of remote servers to store, manage, and process data rather than relying on local servers. We'll be using remote servers to handle the data. Cloud computing typically uses a public or private cloud provider. Okay, what is fog computing? It is known as edge fog computing. It is a model of distributed computing. Okay, the first point involves moving the processing power and data storage to the edge of the network, so that it will be closer to the edge of the network. The processing will be very faster. Moving on, we have the characteristics also, you can go through it. And we have the edge computing, which is the local computing to the process the real-time data. If you want to process some real-time data, you'll be using edge computing. In the context of edge computing, there are various things happening, like the performing of simple calculation or the analytics in real time, or aggregating for the storage. And edge computing has several advantages, you can go through it. Okay, and this is the based on latency, we'll be doing the different types of storage: edge layer, fog computing layer, and cloud layer. High latency and low latency, the based on that you'll be choosing the layers. Okay, that was about the module 1. As I told you, there are few more important questions here, like the following. Yeah, see, this is the one: define IoT. You can always look up at Google what is the definition of IoT. In the starting part of the notes itself, you have the evolution phases of the internet as well. Four phases are there. We are living in the industry 4.0 revolution. Compare IT and OT. IT means internet technology, and OT means operational technology, networks with different criteria. This is for the hardware and this is for the software. What is fog node? We already discussed what is fog, and fog computing model can also be looked up at the notes. Illustrate various access technology with respect to distances in core IoT functional stack. In core IoT functional stack, see, this is the core IoT functional stack, right? Here, different based on different distances, you will be having different applications that comes in communication network. So make sure you go through that also very well. Okay. Moving on to the module 2, what we have is the following questions: characteristics and attributes when selecting and dealing with smart objects. Okay, what are the characteristics and attributes we need to consider when dealing with smart objects? What does smart object mean? It has some IoT concept inside that, so it is called smart object. So few of the characteristics are: processing unit will be checking, sensor and actuators, communication device, and power source, how much power it will be lasting, and what is its battery capacity. All those things we will be looking. Okay, ZigBee or IEEE 802.15.4. In that, totally 5 things are there. In that, they have asked physical, Mac, and security layer, the most important ones. Let's have a look at that. What is it? So basically, 1, 2, 3, 4, 5, 6. These 6 things you have to write for whenever they ask any of the IoT access technologies. There are 4 IoT access technologies. Among them, the most important one is IEEE 802.15.4. Okay. So here they have asked the physical layer, Mac layer, and security. Let's have a look at that. So this is the IEEE 802.15.4. It is a wireless access technology for low cost and low data rate services. Okay, and the applications like the home and the automotive, industrial wireless, interactive toys, all these things form the IEEE 802.15.4. Okay, and one of the application of this one is used by ZigBee. ZigBee is an app which uses this protocol IEEE. Okay, and ZigBee has the following concepts. You can go through it, and this is the layer of ZigBee: physical layer, MAC layer, network, application, and application profile. This is the layer you have to make in the exam also. And in the physical layer, we have direct sequence spread spectrum, and few gigahertz are given, how many channels are there. All these are just facts, no need to explain anything in that. You can go through it. Okay, and keep in mind, and different additional PHY communication options are there: QQ, OQ PHY, BPSK PHY, ASK PHY, and PSSS. All these things are different PHY layers. Okay, and this is a PHY format. Here you have the preamble, start of the frame delimiter, frame length, and physical service data unit. Okay, different kinds of data will be stored in all of these. Okay, coming to the MAC layer, we'll be using the 802.15.4 MAC layer. It manages the access to PHY. There is PHY, and if you want to go to PHY, you have to go through the MAC layer. Okay, so what does the MAC layer perform? The following tasks perform: network beaconing for the devices, PAN association, device security, reliable link communication. And it handles the 4 types of frames: data frame, beacon frame, acknowledgement frame, command frame. And this is the diagram for it. Okay, and from the security perspective, this is the security which is enabled here: auxiliary security, and MIC is used, message integrity code here. Okay, and it uses the advanced encryption standard. DS and ES are the 2 standards, right? Advanced encryption standard with 128 bit key length. Okay, it uses cryptography here to make it more secure. Okay, these are the key points. Moving on, we have explained the wireless sensors and actuators network communication protocol and its limitation. So this whole concept, which is wireless sensors, comes under the topic of sensor networks or SANET. Okay, this is another important question they can ask directly. Define SANET and its protocols. So you have to write about the SANET. It's nothing but sensor actuator network. Okay, where all the devices are there, inside the sensors actuators is there, and those devices are connected by our network called as SANET. Okay, that is only SANET. It offers highly and coordinated sensing and actuation capabilities, and networking also is provided by the SANET. Okay, advantages are given here: wireless sensors networks, it will be transferring the data wirelessly. So these are the main components: CPU power, low memory, lossy communication, narrowband, and power consumption. So these are the different limitations present: limited processing power, limited memory, loss communication, limited transmission speed, and limited power. Okay, and this one of the diagram you have to make how these things are connected. Means in the wireless sensor networks, this is how they are connected. There will be one device here, and all the other devices, 6 devices, will be connected in a hexagon form. Okay, and what are the communication protocol? The main concept which they have asked in the question: WSNs are becoming increasingly heterogeneous, and there are many of the protocols which are being used, which are mentioned here. So likewise, any protocol what we will be choosing, those should be satisfying the context of what we are trying to do. For example, if you want to transform an information in fast amount of time, a protocol specific to that context will be used, like TCP. TCP, no, UDP will be used, because UDP will transfer faster. If you're looking for secure communication, TCP will be used. If you're looking for like parallel communication, will be using asynchronous things, right? Like that, the things are defined here. Okay, and what are the actual standards which are the communication protocol, that is not given here. Okay, so let's have a look at the next question. List and explain the different types of sensors. These are the different types of sensors: active or passive, invasive, non-invasive, contact, no contact, absolute or relative, area of application, how sensors measure, what sensors measure. Okay, these are the different types of sensors which are present here. Okay, and based on these types, there are different applications formed here, like position, occupancy and motion, velocity and acceleration, force and pressure. Okay, and the examples are potentiometer, inclinometer, electric eye and accelerometer, force gauge, and barometer and piezometer. Okay, and based on the flow, acoustic and humidity, biosensors, like there are many types of different sensors for measuring different kinds of things. Okay, so the examples are also given here, and the description is given here. Okay, so that was about the different types of sensors. Moving on, we have the Moving on, we have write a note on LoRAWAN security. Okay, in this security, we'll be using the concepts in which the wireless technologies will be used, like such as low power wide area networks, and they receive a lot of attention from the industry and the press. Particularly well adapted for long range battery powered LPW technologies open in new business. Like basically, what's happening is this is a security protocol which is being used here, and the same things you have to write here. The five things which I mentioned before, like the standardization and alliances is the first thing. Here we'll be having the alliances such as the LoRaWAN, MAC, and physical modulation. So what are the different alliances and the standardizations happening here? It was developed by a French company. That's the first thing, named Cyclo. Okay. And coming to the physical layer, we have the different kinds of MHZ or GHZ. What are the different spectrums it's performing upon? In the MAC layer, we have three different kinds of classes for the different types of transmission of the data. And topology will be using star of stars topology, which is depicted in the diagram here. And security will be using the different kinds of security protecting the communication and data privacy across the network, like LPWAP and LPWANS and LPWAS, LPW device. All these devices ensure the security, and the main concept here used is encryption. Okay, encryption will be used, network encryption inside the app encryption will be there, inside the data will be there. Okay, this is the hierarchy which you have to write, and that was about the module 2. Let's move on to the module 3. We have the first question, discuss the various IoT application transport methods. This is a very important question. Inside that, many questions can be asked, so whatever is given in these notes, make sure you know this very well for the maximum marks. Okay, what are the various IoT application transport methods? There are four methods in which you can transport the IoT. Okay, so what are the four methods? Application layer protocol is not present. Okay, application layer protocol is not present in the first one. SCADA is the second one. Third is generic web, and the fourth one is IoT application layer protocols. Here we'll be using CoAP and MQTT. Separate questions have been asked for 8 marks regarding CoAP and MQTT. All is covered in this same question, so make sure you know this very well. And whenever I'll be passing through the points, I'll be telling you which is the type of the question that can be asked. So stay tuned. Make sure you know this concepts very well. Okay, let's start with the first one. Application layer protocol not present. Okay, if application layer protocol is not present, directly there will be a link between the sensors and the applications. Okay, direct there will be a link by IoT data broker. That is basically what it means. Application layer protocol is not present. Okay, second one is SCADA. In SCADA, we'll be having supervisory control and data acquisition. We'll be controlling, managing, as well as we'll be doing the data acquisition and storage. Okay, so four key concepts are here. Adapting SCADA for IP. How do you adapt SCADA for IP? Tunneling legacy SCADA over the IP networks. The old SCADA is there. We have to make it ineffective with the new IP networks. Okay, and SCADA protocol translation, SCADA transport over LLNs with MAPT. LLNs is another important question. Low power lossy networks. This is asked separately. Okay, so you need to know all these concepts very well. So the first one, adapting SCADA for IP. How do you adapt the SCADA for IP? By upgrading the protocols, what all is present and what are the requirements needed, you will be fulfilling that. Okay, so the detailed informations are given here, like how you will be using, and the examples also given here. You can go through it. And this is one of the protocols and architecture. Here we'll be having the master and the outstation, and here are the different layers: IPv4, TCP, UDP, link frame, transport segment, and application layer. Okay, and there will be logical communication between the outstation and the master. These are the two parallel things happening in between. These are the IP layers, the first three layers, and transport layers, network and data physical layers. IEEE section is present here, which is connection management, and DNP3 protocol, which is the data network protocol. Okay, this is happening here, and basically the logical communications will be happening in between both of these. Okay, so this whole thing is called as a protocol stack. Okay, and the second concept is tunneling the legacy SCADA over the IP networks. Okay, so how do you tunnel the legacy data? Means you will be using the old SCADA and we'll be making some changes in that so that it is applicable with the new IP networks. Okay, so what are the key concepts you need to keep in mind is these are the serial interfaces. Infrastructure is here. These are the raw socket master and the client setups. Basically what you have to know is from the server to the client. Okay, in between that we'll be having some infrastructures and the routers. Based on that you will be transferring the data, and it's of three types. This is the first type of the scenario A, where raw socket is between the routers. Need not pay much attention, just get to know what's happening. There's a client, there's a server, between that some routers are there, that's all. Okay, this is another one which is raw socket between the router and SCADA server, and the third one is raw socket between the router and the SCADA server, and SCADA application knows how to directly communicate using a raw socket. Okay, just make a rough diagram regarding this and write it. Okay, and the detailed information regarding scenarios are given. You can go through it. Next we have the SCADA protocol translation. Here also we'll be having two masters, and between that we'll be having routers and clients, and it will be transferred via the IP network through the IoT gateway to the RTUs. Okay, so this is how the translation happens actually, and by using the IPA protocols. And the last one, which is the LLNs, which is the low power lossy networks. In that we'll be using this kind of protocol here, how it's happening from the endpoint till the SCADA server. Between that the gateways are there, IP WAN is there, everything is same here, just the place in which these things are kept is different. Okay, and the protocols which are using IPv6, MAPT, native IPv4, those are the things that are different. Okay, don't go into depth in these things. This is very technical. It will be very hard for you to understand. Okay, even I did not get exactly what it means. Just remember the rough diagram of it, write some key concepts, you will be getting marks. Okay. And the third point, which is the generic web-based protocol. See, we had how many points here? Four things were to be discussed, right? Four different types of IoT transportation method. These two are done. The third one, generic. Okay, generic web-based protocols. Let's have a look at what is the generic web-based protocols. The web-based protocols not defined for one thing. It can be used for many different things. It's called as generic web-based protocols. Okay, and here we will be having the both the constrained and the non-constrained nodes, which are the examples are given here, and we'll be using the HTTPS, HTTP WebSockets. All those things will be implemented here. Okay, so those are the things which is present here, and extensible messaging and the presence protocol. All these protocols form the generic web interface. Okay, web-based protocols. Okay, and the last one, which is IoT application layer protocols. Here we'll be having two things: COAP and MQTT. COAP is the UDP. UDP means you'll be just transferring without looking if it is transferring with security or not. Okay, MQTT means TCP, means it will be having transmission control protocol. Transport control protocol means it will be having a better algorithm. It will transfer slowly, but it will be in a secure manner. Okay, based on the requirement, we'll be choosing either this one or this one. And separate questions have been asked regarding COAP as well as MQTT. What is it? What are the protocols used? What is its working group? What is the functions of it? All these things are given here. Can go through it. Okay, COAP. Just the facts are given. This is the message field given. By the name itself, you can understand what it does. And same goes for MQTT as well. Message queuing, telemetry transport. Here also you'll be having the clients, and here is the sensor which you are getting, and here is the server. All are connected, and here from that the data will be transferred, and that is only what is called message queuing, right? Just a different type of architecture is there. And remember, in MQTT we'll be using TCP/IP architecture. Okay, because it's secure architecture. Okay, this is the format which is there in the MQTT. You can go through it. Okay, and we have different types of QoS also, quality of service. You can have a look at that as well. There's the variations between the COAP and MQTT. This will just summarize what is the differences between them. It is using UDP, this is using TCP. Request response here, publish, subscribe, excellent, LowPan, and so on. Okay. Moving on, we have the second question, which is a 6TISH in detail. Okay, 6TISH is nothing but a protocol which is used to optimize the IoT. In before time, we don't have the optimized IoT. Now the different devices are coming which are having higher standards. To optimize the existing IoT, we'll be using many techniques. Out of those three techniques, we have 6TISH, which is the second technique. Okay, so what it does is it uses basically time slotted channel hopping. The first key point here. And second, it uses 802.15.4e and TSHCH community. Okay, communicate by the following, and it uses IETF form TI 6TISH group. What this group does is, by using these concepts, time division, multiple access, it will be making the existing IoT standards more better. Okay, and the header compression is given here. It comes in between what is the location of it, IEEE and 6 LoWPAN HC. In between that, 6 top layer comes. Okay, and what are the different mechanisms or the schedule mechanisms? Static scheduling, neighbor to neighbor, remote controlling, hop to hop scheduling. Okay, and here we have the different kinds of forwarding models: track forwarding model, fragment forwarding model, IPv6 forwarding model. This much points you have to write if they ask this question. Okay, moving on, we have IP suite for IoT and the advantages of IoT, IP. Both the things are same. IP suite means what are the different layers present in IoT. Okay, in IoT, what are the different layers present? That is what is the IP suite. For example, you have the fog computing layer. Here we have the lower connectivity layer, data link layer, transport layer, application layer. All these layers form IP suite. Okay, what are the advantages of IP? These are the keywords given. You can find the definitions in the official ones. Okay, so these are the advantages of IP. Very important question from exam point of view. Next, we have the differences between adaptation and adoption. Adaptation means changing one thing at a time. Adoption means entirely changing the whole standard at one time. Okay, like a new protocol. Next we have what is the need for optimization. The following sections takes a detailed look at why optimization is necessary for IP. Okay, so firstly we have the constraint nodes. In constraint nodes you can only do the specific things. If you optimize it, you will be able to do many other things at the same time. And there are three classes of it. The first class is the device with very constrained resources, enough power, and similar to generics. Okay, based on these three we have to make the changes. Next we have the constrained networks. The networks just are very constrained so that it transfers the information at very low scale, and if it is optimized it will be performing the transfer firstly very faster, second more scalable. Okay, and the third is the IP versions. Different IP versions are not compatible with the existing things, which is the IoT. So it has to be optimized so the existing IP versions like IPv4, IPv6 will be applicable with the IoT. Okay, so that is what about the IP versions here. And following main factors applicable to the IPv4, IPv6, and go through it. Here some factors are given. And moving on, we have the routing protocol for low power lossy network RPL. Okay, see, I told you right, LLN. There is only LLN, and there is a routing protocol inside that. Okay, so RPL is the routing protocol for the lossy networks. So here we'll be using the IPv6. So it is just a protocol for the low power and lossy networks, which is having very less connectivity issues. For that, we'll be developing a protocol so that it performs the best given the resources. Okay, the key points you have to write is the first what the definition I told. What is the main concept behind the RPL? It will be for the low power and lossy networks which have very less capabilities. For that, the protocol is defined. Secondly, it uses the IPv6 protocol. Third thing is that it uses the two types of methods, which is the storing mode and non-storing mode. In storing mode, all nodes contain the full information about all the other nodes. In non-storing mode, only the border routers will contain all the information. Okay, and it uses the DAG. That's the third key point. And it also uses another concept called as do DAG. Okay, here there will be multiple children here, and there will be one single parent node. Okay, it will be transferring to the parent node. And RPL messages are also there, like DIO and DAO, which run on top of IPv6. This is the actual implementation of it. This diagram also you have to make. Okay, so these were the key points. Let's move on to the next question, which is 6 LoWPAN protocol, header compression and fragmentation. So why do we need 6 LoWPAN? I already told you, like, there are three methods for optimizing the IP: 6 and the 6 LoWPAN, and another one is there. Okay, so these two are the most asked: 6 and 6 LoWPAN. So let's have a look. This also uses the IEEE 15.4, but not E, just 15.4, and it is a successor of 6 low working group. Okay, 6 low is the older one, 6 LoWPAN is the newer one. Okay, and this is the IP stack reference given here. The different layers are there: physical, MAC, and UDP, TCP layers. And here we have the header stacks. The different fragments are there, different components are present here. What is header compression? Here you have the header and the different formats are there. You will be compressing it so that you'll be utilizing most for the data. So this is how you do the compression. And here is the payload, which is having 108 bits. Before it was only 53 bits. Okay, so that is the called as the compression. The detailed information is given here, you can go through it. Fragmentation means you are maximizing the utilization of the storage. Whether there is empty storage, you will be fragmenting it so that all the empty storage will be in one place and a big empty space will be there. Okay, and you can utilize that empty space for storing the data. Okay, that is called as fragmentation. The diagram is given here, you can go through it. Moving on to module 4, we have the first question: challenges in OT security. Okay, so these are the following challenges in the OT security: erosion of network architecture, pervasive legacy systems. Network architecture is getting old; it cannot be used with the new devices. That is what is erosion of network architecture. Pervasive legacy systems. Again, the old systems are used. Insecure operational protocols. The protocols which are used is the private ones, and that is made public. So there is no security involved. See, it's pretty common sense. If you have something as private, you will not make it more secure in the inner part of it, right? If something is made as public, you will be making it secure from the hackers, right? If it is already private, means it's already secure. But if you take that same private thing and implement it in public sector, at that time there is no security involved, because whatever was hidden, it is made public without any security protocols. That's what's happening in the old IoTs. The security was less, and that is only made as public now because the whole world is using IoT. Okay, so that is what the challenge of the OT security. And device insecurity, again the same thing. Okay, explain the purdue module for the control hierarchy. So this is the purdue module. What is the main use of the purdue module is to control and access the data. Okay, there will be many tools in that, and it also connects the IT and OT. Okay, IT and OT will be connected by using the purdue module, and it is for the control hierarchy at different layers. The control has to happen. So that's what it's mentioned here, like safety critical, base process, basic control, supervisory control, and so on. All these things are the different zones in which the control is happening, and in different layers, like enterprise zone, DM zone, demilitarized zone, and here we have the SCADA zone, and here is the safety zone. Okay, based on that, the hierarchy is defined. You just have to explain what are the different applications happening at each layer. For the more information, you can refer the official notes. Okay, and here we have the different levels also, what's actually happening, and go through it. So those are just the facts. I'll not be explaining that. Let's move on to the next question, which is OCTAVE and FAIR formal risk analysis. What is OCTAVE, what is FAIR? OCTAVE and FAIR, by the name itself, you can understand operationally critical threat, asset, and vulnerability evaluation. It is accessing the risks involved and the threats involved, and it is reducing it. What is the first thing? This is the phases you have to write here. First is step one is establish risk measurement criteria, develop the solution, identify the areas of concern, identify the threats, identify the risks, and analyze the risk and implement it and make the risks lesser. Okay, and FAIR is also the same thing, factor analysis of information risk. Again, it does the same thing. Few technical differences are given here, you can go through it. Next, we have compare the big data, edge data, and network analysis. What are the differences between them? So, big data is nothing but it will be just concerned with storing the data in a most efficient manner. Okay, and the edge analytics is based on handling the data and processing it. Okay, edge analytics also requires that. Last one, which is network analysis. In network analysis, we will be having the transferring the data from one part to another. That also. Okay, so big data stores, edge data processes, network data transfers the data. Okay, so here the architecture is given how is actually transferred the network layers. You can go through it. Okay, moving on, we have the different types of data analysis results with the example. Four types of data analysis are there, which is descriptive, what's happening; diagnostic, why it happened; predictive, why it's likely, or what is it likely to happen; prescriptive, what should I do about it. And these are the different technologies of the big data used here, and this is the data, different kinds of data, and all these data can be classified either as descriptive, diagnostic, predictive, or prescriptive. And more information given here, you can go through it. Okay, next we have differentiate between supervised and unsupervised machine learning. What is supervised means you'll be having already defined classes, and based on that the data will be classified either class A, class B, or class C. But unsupervised means what? You'll be having just the data and no classes are defined. Based on the similarities, there will be classes formed. These things are similar, these things are similar, these things have similar features. That is called as unsupervised machine learning. Okay, moving on, we have explained the elements of Hadoop with a neat diagram. So Hadoop is nothing but it is a data storage architecture, data management, and the data storage architecture. Okay, it has HDFS, Hadoop distributed file system, MapReduce, and yeah, these two things are there: Hadoop distributed file system and MapReduce. Here is the distribution switch, and these are the rack nodes and the data nodes present here, which store the information. Okay, and two types of nodes are there: name nodes and data nodes. It stores the names and stores the data. Okay, and this is the diagram with respect to that. Okay, next we have what are the common applications of machine learning in IoT. In IoT we have the four different kinds of applications in the IoT: monitoring, behavior control, operations optimization, and self-healing of self-optimizing. Okay, so if you go through it once, you will get to know what it actually means. Basically, it's self-explanatory. Whatever that term suggests, that only it is. Okay, and the ninth question, which is the discuss Hadoop Lambda architecture. Okay, what is the Lambda architecture? It is used to do the two things: streaming and batch processing. Okay, so this is the architecture defined for the streaming and batch processing. Here we have the smart objects. It sends the data to the Kafka, and from there the stream layer is here and the batch layer is here. Both process the data and gives the real-time views. It gives the pre-compute views, and both merge and give the output as the merged view in the serving layer. Okay, that only you have to explain. And if you want more information, it's given. You can go through it. Okay. Moving on to the module 5, we have the following questions. So let's have a look at each of these one by one. The first question: explain the following with respect to Arduino programming, structure, variables, functions, and digital I/O. What is Arduino? Arduino is nothing but it is a board in which you can use to perform some task which is related to IoTs in the computer. Okay, like sensing the things and doing some actions. Okay, so these are the structures with different components are there: power LED, microcontroller, analog input pins, power pins, power jack, and reset button. Okay, This is if they ask you about the architecture, but structure actually means in the programming. Okay, like this structure, it has two things: void setup, in which the setup things will be done, and void loop, in which looping statements or the iterative statements will be done here. Examples are given here: pin model, pin and input, pin configures will be done here, and loop means whatever has to be done repeatedly, like on and off here. In this case, it is given, that is also mentioned in the looping part. Okay, that was about the first one, structure. Moving on, we have the second, variables and the data types. In variables, it's a way of defining thing in which you can store some data. Okay, like variable, we all know what it is. I'm not going to explain this one. Data type, different data types: byte, int, long, float, and arrays. And you have the functions. What is the function? Defined between the curly braces. In between that, if you write some statement and you call that function by its name, that function will be performed. Okay, example is given here for the delay variable. Okay, and for the digital input output, you'll be using different kinds of pin modes: digital read pin, digital write pin. Example is also given here. Okay, so moving on, we have with an explanation which is the different layers of smart IoT architecture. This is smart layer IoT architecture. Let's zoom in a bit. Basically, you have to remember the four layers which is present here: street layer, city layer, data center layer, and services layer. The data from the street layer is sent to city layer. Data from the city layer is sent to the data center layer, and from here it is sent to the service layer. Whatever is happening in each of these layer in depth, it is given here. You can go through it. In street layer, basically what's happening is you'll be getting the data from the streets. The sensors are attached in the streets. All that data will be collected, and that will be forming a city data. Means all the streets are forming a city, right? And all the cities will be forming a data center in the center of a country. Okay, and that will be providing some services. Okay, so whatever is given here, that's the same thing which I summarized for you. You have to make this diagram and write the whatever is happening in each of these. Okay, moving on, we have the third question, which is explain the smart city security architecture. For the security perspective, what all is required for the sensors? Which are the sensors required? Why security is required? All those things you can write from my own words. What are the different types of sensors required? That I can show you here. Like these are the different kinds of securities involved: firewall, LAN, and encryption. Okay. So and what happens if you implement a security architecture? The following things will happen: like the public will be safe, basically, right? And the data of the public and the industry will be safe. IT structure, infrastructure will be secure, and the hijacking will not happen, right? Or else what will happen if the hijacking happens in the street layers? What will happen? All the signals can be turned green, and there will be many accidents, right? So that's why security is important. Okay, next we have smart city control, traffic control architecture. Basically, to control the traffic, you need to know what is the size of the vehicle, what is the number of vehicles traveling in one street, how it can be optimized if why the signals are made as green or red. Okay, basically that type of architecture using sensors. Okay, that is only smart city traffic control. After adding that much, you have to add the architecture which is given here. Different layers are there: cloud analytics, platform, and partner applications. Okay, based on that, you will be getting the data from these sensors here, and from the car data, you will be detecting the cars, counting the vehicles, all those things. Okay, and it will be sent to the final apps, which will be showing the optimized solutions what is needed to be done. Okay, moving on, we have the write a short note on Raspberry Pi operating system and the commands used. Two things: what is Raspberry Pi, what is the operating system, what is the command used. Okay, so introduction to Raspberry Pi. It's a credit card sized programming thing which is used for doing the automations. Okay, like for example, whatever you need to do by using the like how we did in Arduino, like that only Raspberry Pi is also there. Okay, let's just slight differences there. So operating system, if it is Linux based or not Linux based, different operating systems are given here. For the media center also, different operating systems are given here. Okay, basically if they ask about the OS, you have to write this and this, that's all. Okay, now it's based upon how much you remember, you can remember. Okay, and what are general commands? Here general commands are there, like for example raspberry config for configuration, clear for clearing the data, date for date, and so on. Like that we have for the directory and the file, make directory, move directory, remove directory, and so on. Networking, IP config, IF config, ping, and wget. And here we have the system information commands like cat, df, and free, hostname, and so on. All these commands are given here. Just briefly go through it. Remember these things. Since system information commands is there, we have the network and internet commands is there, directory and file commands is there, and last one which is general commands is there. Okay, so you can write at least 2 or 3 from each of these. Okay, Moving on, we have the next question, which is write a short note on DS18B20 temperature sensor. It is a sensor which is used in Raspberry Pi for detecting the temperature. Is the temperature more high or low? What is the technical aspects of it? That's given here. Okay, about DS18B20, that's only what I told you. That's only given here. It uses the transistors for detecting the temperature rise or temperature fall. Okay, it uses the 64-bit ROM, and it is the same size as transistor. See what I told you, all these are facts. Okay, there's no need of explanation. If you just go through it once, you'll get to know. Okay, technical specifications is given here. Pin diagram is also given here. You can go through it. Okay, next we have, right, with a neat sketch, explain the street lighting system. Like these are the streets, and here the lights are present, right, the street lights, and when it should be on, when it should be off. Based on that, optimizations answers will be found out, and we will be implementing it using IoT. Okay, so how we will be implementing that, informations are given here in the architecture. How actually we'll be implementing, we'll be having different layers like the cloud layer, data management, and light auction and events, sensor gateway. When is the car coming, that time only the light will be on, other times it will be off. It will save the electricity. If any person is coming, it will detect the person is there, it will on the light, off the light based on that. And in the morning times it should switch off. In the night times, based on the temperature or based on the weather conditions, it should increase or decrease the intensity of the light. All those things will be considered by using the sensors, and that will be sent back to the end users apps. Okay, in that way the smart infrastructure is implemented, and basically you have to make this diagram and write a few keywords regarding that. Moving on, we have the last question, which is explain the neat diagram, smart parking system. How can we means what happens if you make a smart parking system? It will means the use cases are that it like the contribution to the pollution will be reduced if the people spend less time in the finding the parking, and it reduces the frustration of the motorists, and it decreases the traffic incidents, and the cities often lose revenue when there is less parking areas, and administration employee productivity suffers. The employees will be suffering for telling the persons where to park the car. So how can you make it a smart way? In smart way, you can attach sensors wherever the place is empty. By using magnetic sensors, you can see if there is a car or not, right? Magnetic field will be high if the car is near. If it is not there, you can sense that car is not there. You can use the sensors for detecting dust particles. If a car has come, there will be huge amount of dust particles present. Based on that, you can say if the car is present or not. You can use a camera. Camera can detect if the car is there or not by using OpenCV, right? Like that, many different types of sensors are there. You can write any of those, like at least 3 of them. You can write in the exam. Okay, that's what. And the architecture is given here. You can go through it how it actually is. Here's the sensors are there, and the data is sent back, and the processing happens, and the final solution comes to the end users and the devices. Okay, that's all for this video. Make sure the like button, subscribe to the channel for more videos like this. Don't miss any question, and thank you so much for watching. I'll see you in the next one.